When scheduled payments are replaced with a new set of payments, we need to ensure their values are equivalent at a common point in time. Using a focal date and compound interest, we'll calculate the balance payment that makes both sets financially equal. Here's an example. Scheduled payments of $1,300 due 1 year ago and $900 due 6 months ago are to be replaced by a payment of $750 now, a second payment of $1,100 9 months from now, and a final payment 18 months from now. What is the size of the final payment if interest is 10.8% compounded quarterly? To tackle problems like these, I like to begin with a timeline. According to the first sentence, there are 2 payments that are currently overdue. So using a timeline, I'll write down that today is at this point, and the $1,300, which was due 1 year ago, will be over here. So that's 1 year ago. And also 900 6 months ago, so somewhere here. So those 2 you haven't paid for yet. Furthermore, you're expected to make a $750 payment today, another one 9 months from today, worth $1,100, and finally, one more payment 18 months from now. So somewhere here. And we don't know how much that value is. Now that I've created my timeline, my next step is to find out the future value of this overdue payment today and the value of this overdue payment today, and sum them up. And to find the future value, we use the compound interest formula, or the future value of compound interest. Fv is equal to P, and in parentheses 1 plus I to the power of n. I represents your interest rate per period, and n represents the total number of periods. I can be broken down into your nominal interest rate R divided by T, the compounding frequency per year, and n is broken down into m, which is the duration in years, times your compounding frequency t. So to find out the future value of 1,300, all I have to do is substitute 1,300 into P, 1 plus, our interest rate is 10.8%, which translates to 0.108. It is being compounded quarterly, so our t value is 4. And because it's being fast forwarded to today, and it was due a year ago, that makes 4 compounding periods. So m would be 1, and t would be 4. 1 times 4 is 4. So let's find out what this value is. 1,300 times 1 plus 0.108 divided by 4 raised to the power of 4. So the future value of that overdue payment is 1,446.19. And we'll do the same thing for the 900. So let me do this really quickly. I'll replace the 1,300 with 900, and that was due 6 months ago. Therefore, the value of n is not 4 this time, it should be 2, because 2 periods, given that it's compounded quarterly every 3 months, 2 periods pass from 6 months ago to today. So I'm going to replace this 4 with a 2. And we end up getting $949. So let me write that down. And I'll round this to 2 decimal places where it's 0.26. I'll go ahead now and add that number and the one that we found, 1446.19, together, and that makes a total of $2,395.45 today, which, by the way, you have to make a payment of $750 today. So I'll subtract from that sum $750. This means that I still owe $1,645.45 today. Let me write that down somewhere here. $1,645.45. That is how much I owe today. The next step is to find the future value of $1,645.45 9 months from today, and then subtract from it $1,100. So let's find another future value. And our principal now is 1645.45. The stuff within the parentheses stays the same. And we need to find out how many compounding periods happen from today to 9 months. Because it's quarterly, we have 3 periods that pass. And once we find the future value, we'll subtract 1100 from that. So the number on our screen times 1 plus 0.108 divided by 4 raised to the power of 3, it matures to $17.82.36. And then we subtract 1100 because you're making a payment. And this will tell us how much is left that we owe for that very last payment. And so we owe $682.36. Now, we have one more calculation. We need to find the future value of this amount, $682.36, 9 months from that date. So for our final future value, we'll know our final payment. We have 682.36, 1 plus 0.108 divided by 4. How many periods pass from 9 months to 18 months? That's 9 months, so it will be 3 periods. So we take 682.36 and multiply that to 1 plus 0.1008 divided by 4 raised to the power of 3. Therefore, our final payment will have to be $739.14. If you have any questions about my approach, please leave it in the comment section below and I'll gladly give you a hand and help you. Thanks for watching.